In the last lecture, we had concluded with a term called algorithm. And we said that an algorithm means a sequence of steps that are followed to solve a problem, to be followed to solve a problem. Now, the question is that how do we express an algorithm? How do we express the sequence of steps? How do we express that? There can be different ways of expressing it, right? So, usually, ultimately we will have to write a program for this. Ultimately, we will have to write a program for this. So, obviously, program is the final form of expression of the sequence of steps that we want to reach to. But even before that, a program is for communicating the sequence of steps to a computer, but even for our human exchange, we may like to express what are the steps to be followed. There are two distinct ways by which an algorithm can be expressed. One is flow chart, another is pseudocode. Now, a flow chart, as the name implies, is a diagrammatic representation of the sequence of steps. It is a diagram, all right. And pseudocode, on the other hand, is an English-like, English or whatever in human language, English-like, not exactly English. We can take a lot of liberty, you will see how to, when I express the sequence of steps, English-like language to express the sequence of steps. Okay. Now, we will show both the flow chart and pseudocode with respect to some of the problems that we had discussed earlier. Okay. So, let us start with this, finding the average of three numbers. This is the simplest possible way, simplest possible problem that we can solve. So, we will start with the first, we will start with the start node. We are trying to draw a flow chart. So, once we draw the start, then next will be sum assigned 0. Now, what all of us know that in order to find the average of any number, set of numbers, we have to first add those numbers. So, the addition result is stated as sum. So, here we are, when there is no number that has been we have already taken into account, we initialize the sum to be 0. So, right now sum is 0, right. Next what we do is we read the first number, read number 1. Now, what does this read mean? Read means who is reading, whom do you want to read? Whoever will be finding the average, he or she will have to read the number. If I ask a human being to do that, the human being will have to know the number. So, if I show that number on a piece of paper writing 5, he will read that number 5 and will say okay. So, 5 is the first number. Then I show the second number 7, okay, 7 is the second number. In that way, that is the significance, that is the meaning of this read. Now, in our case ultimately the computer will read it, and earlier we had talked about the input, and often we had discussed about this. This is also known as an input mechanism. So, it is reading the number. Now, here I would like to state a few things, that is say flowchart has got some basic fundamental elements. This one you have already seen, that is a start symbol. Okay. Now, this figure is known as oblong. This figure is a rectangle. Now, this oblong is actually used for input and output specification. Wherever I need to do some input or the system provides me some output. Let me explain this. So, input I have already explained, that when I am writing some number for you to read or for anybody who will do the computation to read, that is the input. And you know, all of you, that we have got some input devices. The most standard input device is the keyboard, using which we can put in the data. The output is, after the computation is done, the system will give me the output, or if it be a human being who is doing the computation, he or she will be telling me the output, that this is the result. So, that is known as output. So, while drawing the flowchart, sometimes we will write read for this input and maybe print or write for output. Okay. Now, this diagram is essentially the computation box. So, whenever we do some computation, that we show in this sort of a box. For example, we can say x is p multiplied by q, something like this, or okay. The other very important block is the decision block, which looks like this, a diamond. Now, here what we do, we just take decisions depending on some conditions. Depending on some conditions, I will either take the left path or the right path. Okay. So, for example, I can say whether the age of a boy is greater than 14. If the age of the boy is not greater than 14, he is not allowed to go to a film. Okay. So, if it be no, then he cannot go to see a particular film, and if it be 14 or greater, that means it is greater than 14. If it is yes, then he can go to a film. So, we come to this particular point and make a decision looking at this sort of scenario. So, this is known as the decision box. Now, these are the basic 4 elements of any flow chart. All right. So, now we will again come back to our flow chart. So, you can see here that sum is 0 and the number that has been read is the first number, right. Now, suppose that number that was read, the number that was read is 5. Suppose the number that I read is 5. So, some number. So, next what I do is I add that particular number with the sum. So, now the sum was initially 0. So, I add 5 with sum. So, it becomes the total sum becomes 5, right. Sum becomes 5. So, next what should I do? After I computed the sum, then I read the second number, because I have to read 3 numbers and find the average. I read the second number and then I add the second number with the sum. The first number was 5. So, the value of sum is now 5. Okay. Value of sum is now 5. I have read the second number, suppose that was 8, then the sum becomes 8 plus 5, that is 13. Now, I come and read the third number, suppose it is 3. All right. So, I read the third number and then I compute the sum. So, I have computed the sum to be 13 plus 3, 16. Next, what do? I have to compute the average. So, what I do? I find the AVG is, by AVG I am depicting the average. Average is sum divided by 3. Okay. So, it was what was it? 13 plus 3, 16 divided by 3. So, it will be 5 point something. So, that result whatever I get, that I will be printing. So, that is a flow chart. These are the steps that I have to do. Okay. Now, the same thing I can express in the form of a pseudocode or English like language. Let us see how it looks like. Here you just see what I have done. I have initialized what I wrote in the first step is this one, is equivalent to this. All right. Initialize the sum to 0 and then I read the first number. Sum is added, sum equals sum plus number 1, exactly what I did here. Read the second number, then I sum equals sum plus number 2 and then I read the third number and then sum is sum plus number 3. So, these are the steps. You see exactly, if you just do not look at the left part of the whole thing, if you just look at this right part, you can also understand what are the steps through which I must go. Okay. And so, ultimately I compute the average, which is I just write. So, it is English like compute AVG equal. So, it is not exactly English, it is English like. Anybody who knows English will be able to understand this. So, this is known as the pseudocode. So, this is for the very simple problem that we are doing. Now, suppose let us think of for a second that suppose instead of 3 numbers, I ask you to find the average of 10 numbers. How would the flowchart look like? Obviously, this same thing that I have done here, read number 3, read number 4, read number 5, read number 6, in that way it will go on and on and on. Okay. Had it been 100 numbers, then it will be even larger. Okay. Now, can we do something better in order to, I do not have so much paper to waste. So, can I write it, can I express it in a much better way. So, let us go to the next problem where we want to find the average of n numbers, average of n numbers I want to find out. So, the first thing will be again start, that is from where I am starting. Next is read the value of n. So, what is this value of n? Now, if I say this value of n, when I read, what is this n? This n is telling me how many numbers I will be considering for finding the average. Is it 100, is it 1000, is it 10, whatever. So, I am, that is n. So, I am reading the value of n. Okay. Now, I am initializing the sum to 0. Again, just as before, I initialize the sum to 0 and then I read. Now, you see here I have written read number. I have not written read number 1. Earlier, since I had to only do number 1, 2 and 3, here there I wrote down number 1, number 2, number 3. Here I am just writing read number, okay, because I do not know how many numbers I will be reading. The reason will be very clear soon. So, next what do? I read the number, then sum is sum plus number. So, I take the sum was 0, I take the sum and add that number. Which number? The number that I just now read. Say I have just now read number 5. Okay. I have read just now, I am sorry, I just read number 5. So, I read number 5 and I have added that number with sum. So, sum is now 5. Okay. Next, I decrement. This is a new thing that is coming up here. Since I know here at this point the user or the whoever supplied the data told me that you have to look for 100 numbers, say n is 100. I have learned that. So, now here I have read one number and I have taken care of that number because I have added that with sum, and so therefore, I now decrement that value of n. What does this signify? This signifies that I now, since initially it was 100, I have to read 99 more numbers. 99 are yet to go, right. Now, I have to check, have I read all the numbers? What is the value of n? The value of n is 99. That means, n is not 0. That means, I have not been able to read all the numbers. If I have, since in a decision box, as I have told you just a couple of minutes earlier, that I can have two options. I can either have yes or no answer. If n is equal to 0, what does that signify? If n is equal to 0, that signifies that I have read all the numbers. I have already read all the numbers. Then I can compute the average as sum, whatever sum I got divided by n. Otherwise, if n is not equal to 0, then let us look at here. If n is not equal to 0, no, then I will go back here again. Look at this part. I will go back here again and read number. I will read the second number, read the and add it to sum. I will go over here, decrement. So, I have read two numbers. So, now how many are yet to go? 98. N is 0? No, n is not 0. Okay. N is not 0. So, I go up again, I read another number, add that particular number to the sum, decrement n. How many to go? 97. Is it 0? No, not yet 0. So, I go on in this way. I will go on in this way. Ultimately, after I have read the 100th number, this n will become 0. So, at that point I will come to this average and compute the average as sum divided by n, and then I will print the average and stop. So, see, just by this thing, I am sorry, just by this thing, which is nothing but this is called a loop. This is called a loop, and using this looping repetition, I could reduce the length of the flow chart, the repetition of the flow chart in a very elegant way. I hope it is clear. So, the same thing can be also reflected in the flow chart. Now, compared to with the earlier flow chart, earlier statement here, when I read it only for 3 numbers, I did initialize sum to 0, read number 1, read number 2, and at every point I was adding it to sum. Here what I do is I write it in a little bit flexible way, because when I write in a pseudocode, I am not very constrained. I can take the flexibility. As long as I can express myself, it is good enough. I just wrote get the value of n. Earlier probably I wrote read the value of n, means the same thing. So, get the value of n, initialize sum to 0, and till now here I am talking of this looping till n is as long as, till means as long as n is greater than 0, it will be better to say as long as n is greater than 0, read a number add the number read, the number that you have read to sum. You read a number, add the number read to sum. Okay. And one thing I missed out here, and you decrement n. You decrement n here. You have to make n equal to n minus 1. In your note, you please take it down that here it will be n minus 1. And so, this will till n is, as long as n is greater than 0, I will be going on doing this. After that, I will compute average as average divided by sum, average is sum divided by n, I am sorry, and then I will print the average. So, I can express it either in the form of a flowchart or in the form of a pseudocode. Okay. Now, let us take a I mean it is not very visible here, finding the maximum of 3 numbers. That was another problem that we had discussed last time. What I am trying to do is, I am trying to find the maximum of 3 numbers. So, how can I go about in doing the flowchart? So, I start just 3 numbers, not a large set of numbers. I first read the number 1. Now, tell me one thing, when you have first read one number, what is the maximum number? Obviously, since you have read only one number, that itself is the maximum, only one. So, it is a singleton, so it is the maximum. Therefore, I say that max is nothing but the first number, the number that I have read, max is number 1. All right. Now, I read the second number. Okay. I read the second number. Now, which one is the maximum? If the second number is greater than the first number, then the second number will be the max. Now, when I read the first number, here, I set that to be the max. So, now after reading the second number, I can compare the second number with respect to the max. If the second number is greater than the max, then what will happen? Then number 2 will be the max. Okay. If it is yes, then number 2 becomes the max, and if no, that means what? Number 2 is not greater than the max, then I skip this part. I skip this part and go out by this way, skipping this part. That means, at this point who is the max? Obviously, at this point I had number 1, and number 1 is still the max. Okay. I hope it is clear. Next, I read the third number. Again I do the same thing after reading the third number. Is the third number greater than what? Number 2, should I compare? No, I should compare with the max, because till now between number 1 and number 2, whatever is the maximum, I have already remembered that in max. So, I read the number 3 and then again compare, is number 3 greater than max? I can have yes or no. So, if it be yes, then number 3 becomes the max, because number 3 is greater than the maximum number till now. Okay. And then I will proceed, and if not, if number 3 is not greater than max, then then obviously the whatever was the max till now, that is the number 1, that will remain the max. Okay. Think of number 1 to be 5, number 2 to be 3 and number 3 to be 1. What will happen? 3. So, max is 3. Sorry, this was 5. So, I read 5. Okay. Next, I read 3. Is 5 greater than 3? No. So, I kept 5 as the maximum. All right. I read number 3, that was 1. I compared, is it greater than the maximum which was 5? No. Then I print that 5, which is the maximum. But if suppose number 3 was 7, so it is greater than 5. So, then I can go here and update this max to be number 3 or the 7, and then I come to the print max part. So, this is the flow chart of finding the maximum of 3 numbers, and consequently you can see the pseudocode of this: start, read first number, then I assign max to be the first number, then I read the second number, assign. Now, if number read is greater than max, then I will make the max to be number 2. Okay. If the number read, if it's badly written, read number, it is wrong. If number 2 is greater than max, then make max number 2, all right. Then read number 3. If number 3 is greater than max, then make max number 3, otherwise you are continuing. So, if number 2 is not greater than max, then I am reading number 3, I am not doing this part. Okay. This is another way of explaining the pseudocode. So, the same thing. Now, we come to another variety of this, finding the maximum for n positive integers. Here I have taken a little liberty, finding the maximum of n positive integers. Earlier I was doing it for all numbers, but just as a change. So, let us see. I read n again. N means the number of numbers that I want to read. Now, I set max to 0. Why do I set max to 0? Because I am trying to find the max of n positive integers. So, any positive integer will be greater than or greater than 0. So, I am putting that max to the minimum value possible, and then I am reading a number. I read a number, and if that number is greater than max, which is by default 0, I have kept it at the bottommost possibility, right. In all, unless that number is 0, it will always be greater. So, I will set that number to be the max. Next, again you remember what I did for finding the average, I reduce the value of n. Suppose I had to find the max of 10 numbers. So, n becomes now 9, and then I check, all right. If the max, sorry, this is mistake here. This arrow should come from this point. This arrow should come from this point. So, I am just drawing it here. I am drawing it here. It should come like this. So, I have read a particular number, and then if that particular number is greater than max, I am sorry. I read a number, and if that number is greater than max, then I will, if it is true, then I will make that number to be the max, right. Max will be that particular number, and then I check n. I have already read n. So, is n 0? Then I have read one number, and then I reduce n, just as I did in the earlier case, and then I check n greater than 0. If yes, then I have to go back. And again read a number, right. read num, and this will go on as long as n is greater than 0. If n is greater than is not greater than 0, no, then I will come and print the max, right. So, there was a little error in that diagram which you will be. So, you can see that this line should have come from here. Is n 0? Yes, then print max, otherwise this should have come from this point, all right. This should have come from this point, this is wrong. Okay. So, in this way we can again find the max for n numbers, it is a flow chart. So, again I can have the pseudocode for this. So, the pseudocode for this is shown here. Read the value of n here, initialize max to 0 till n is 0, read the number. If number is greater than max, max is equal to number, decrement n is n minus 1, and then it will be not 1 here, it will be again print the max. So, in that way you have seen examples of some intermediate representation of the sequence of steps of the algorithms. We will encounter a number of algorithms in the course of these lectures, and at the next point, next step, we will see what is to be done in order that this sequence of steps can be converted, can be transferred to a computer language, so that and can be transferred to a computer, so that the computer can solve the problem. That we will see in the next part.